This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyers, Space Coast News Editor. You've probably seen a movie or TV show in which characters endure long space flights by being put into stasis or hibernation for the trip. Aliens, Star Trek, Passengers are some of the examples that have used this plot device. Well, it may not be quite so much science fiction as we thought. The European Space Agency is researching human hibernation for long duration spaceflight to Mars and beyond. Hibernating astronauts could be the best way to save mission costs and supplies, reduce the size of spacecraft, and keep the crew healthy on their way to Mars. An ESA-led investigation suggests that human hibernation goes beyond the realm of science fiction and may become a game technique for space travel. Astronauts could be placed in torpor, which is an induced state that reduces the metabolic rate of an organism. Reducing the metabolic rate of the crew to Mars down to 25% of normal state could dramatically cut the amount of supplies and habitat size, making long-duration exploration more feasible. Here are some ESA scientists to explain what is involved.
Did you know that hibernation in space could be more than sci-fi only? The state of hibernation is close to what is called torpor. That is the state in which living organisms reduce their body temperature and metabolism. Hibernation has been studied in ground-based experiments by ESA's Science and Exploration Research Program, and the results are promising. Hibernation does not only promise to have positive effects on astronauts' health during long-term stays in space, but it can also enable more cost-effective space missions, as there will be less food and energy needed during the travel. ESA is currently financing studies aiming at optimizing protocols for long-duration flights. The results so far obtained proved we are on the right path. Benefits are not only for astronauts, they also promise to reduce the negative impacts of anesthesia in surgical procedures here on Earth. Research into torpor induction is seeing a strong potential for even a wider range of applications. ESA is looking to find a way of inducing torpor into humans for extended amounts of time, as well as creating hibernation-ready habitats and artificial intelligence support systems. By bringing hibernation technology from sci-fi into reality, ESA will be able to help many people here on Earth in the future.
Jennifer Nolan explains how hibernation could help reduce challenges to the astronauts.
With the current technologies, it will take astronauts about 9 months to reach Mars. They will then spend about 3-4 months on the Martian surface, and it will take them another 9 months to return back to Earth. A crew member will need about 30 kilograms of food, water, air, and other essential consumables per day. On top of that, there will be health challenges. The astronauts will be exposed to microgravity for long periods of time. They will have to rely on their spacecraft and on their crew members, so there will be a mental challenge. And above all, they will be exposed to cosmic radiation, which has long-term effects on their health. Now, how about we avoid all those cargo and health issues and challenges by putting astronauts to sleep during their space journey? How about we send hibernating astronauts into space?
And Griini Posipatari explains how hibernation protects astronauts from radiation.
Invisible to the eye, but present in vast amounts in space, is radiation. Exposure to radiation may lead to cancer, cataracts, or damage to the central nervous system, but hibernation may be the key to keeping astronauts safer by mitigating the radiation risk on long space journeys. ESA has been funding a group of scientists studying the effects of torpor induced in non-hibernating animals.
Hibernation or torpor as radiation protection tools is important as radiation are all around us. Every day, we are exposed to a variety of radiation on Earth, though there is no reason to be scared. The vast majority of it is naturally occurring and not harmful. The radiation protective effect of torpor on hibernator has been studied in experiments since in the 60s. Since the 2000s, hibernation has been artificially induced in non-hibernator such as rats. We had previously experienced centrally drug-induced hibernation in rats and show radiation protective effect on the organ such as the liver and the testicle of the rats after photon radiation during hibernations. Currently, in collaboration with Japan, we found that synthetic hibernations or torpor on rats also has protective effect following heavy iron radiations. Our current study showed a significant increase in survival and show radiation protection in some organs, which might be helpful for future space missions.
Alexander Choker explains how to induce torpor in human beings.
The possibility of hibernation for medical use is of particular interest to the European research community and could transform how we approach many severe illnesses. Inducing torpor is already used in some medical and surgical theaters to replace anesthesia in those patients allergic to anesthetic drugs.
How can we achieve this state of torpor in humans? What are the next steps to take? From all the knowledge we gathered from animal research and experimental research, the way the bear does might be well for humans to enter torpor in a wave-type fashion. So it may take a couple of weeks to enter torpor, then a pharmacological intervention might be needed, which may include also central nervous acting drugs to induce this state. The maintenance of torpor, which is in the longest period, needs to be understood, safely conducted, and may include as well environmental conditions like temperature in the pod, oxygen tension, and other factors. And then the recovery or the arousal from the torpor needs suitable measures which can be changing in this environment or pharmacological or drugs to wake him up, so to say. And we should also keep in mind after this period of 5, 6, 7 months of torpor, we need to recover also and get back to normal activity, and this may need some exercise and activities to be then really ready to land on the planet Mars, for instance.
So eventually astronauts may be able to sleep their way to Mars. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.